Good morning, ma'am. Myself Satvika. I'm from CSE department. Today I'm going to explain a question from discrete mathematics to find a generating function for the recurrence relation A when a of n plus 2 minus 3a into n plus 1 plus 2a into n equals to 0. That where n greater than or equals to 0 or when a naught equals to 1 and a1 equals to 6. First, we should find a recurrence relation for the question. For the given question, we are given the recurrence relation for your a base n plus 2 minus 3a base n plus 1 plus 2a base n equals to 0 for n greater than or equals to 0 with initial conditions a naught equals to 1 and a1 equals to 6. Now let us follow some steps to solve this question. Step 1 is to find the characteristic equation. First, rewrite the recurrence relation as a base n plus 2 is equals to 3a base n plus 1 minus 2a base n. The characteristic equation corresponding to this recurrence is r square minus 3r plus 2 equals to 0, factoring r minus 1 into r minus 2 equals to 0. Thus, the roots are r equals to 1 and r equals to 2. Coming to step 2, general solution to the recurrence, which means we are finding the general solution to the recurrence value. The general solution to the recurrence is of the form that is a base n equals to a into 1n plus b into 2n, that is means that proves as a plus b into 2 base n. Coming to the step 3, to use initial conditions. We now use the initial conditions to find the values of a and b. For n equals to 0, we have a naught equals to a plus b into 2 naught equals to a plus b equals to 1. So we have the equation a plus b equals to 1 here. For n equals to 1, we have a1 equals to a plus b into 2 1, that equals to a plus 2b equals to 6. So we have the equation a plus 2b equals to 6 here. Coming to step 4, to solve for a and b. We now solve the system of linear equations now. So a plus b equals to 1 and a plus 2b equals to 6. We have two equations which are solved in step 3. Now let's go to the step 4. Subtract the first equation from the second, which means a plus 2b minus a plus b equals to 6 minus 1, that is b equals to 5. Now substitute b equals to 5 into a plus b equals to 1. So a plus 5 equals to 1 and a equals to minus 4. N equals to minus 4 plus 5 into 2n. Step 5, to find the generating function. The generating function g of x for the sequence an is given by g of x equals to sigma n equals to 0 to infinity an into xn. Substitute the expression for an, that is g of x equals to sigma infinity to n equals to 0 into minus 4 plus 5 into 2n into xn. This proves next as g of x equals to sigma infinity to n equals to 0 minus 4 into xn plus sigma infinity to n equals to 0 5 into 2n into xn. Next step comes as g of x equals to minus 4 into sigma infinity to n equals to 0 xn plus 5 and sigma infinity to n equals to 0 into 2x into n. Step 5, to find the generating function. We're continuing this. Now we use the sum of a geometric series, which is sigma infinity to n equals to 0 xn equals to 1 by 1 minus x for x less than 1 and sigma alpha to infinity to n equals to 0 into 2x whole n equals to 1 by 1 minus 2x for where x less than 1 by 2. So this proves as g of x equals to minus 4 into 1 by 1 minus x plus 5 into 1 by 1 minus 2x. We substituted the values in the g of x. Thus the generating function for the sequence a base n is g of x equals to minus 4 by 1 minus x plus 5 by 1 minus 2x. Thank you, ma'am.